You've heard the expression about something being more than the sum of its parts. Well, in this video, I want to suggest that dy by dx, this notation for the derivative, is more than the quotient of its parts. Okay. I know this represents the slope of the tangent line, and I know that dy on its own represents the rise of the tangent line, and dx on its own represents the run of the tangent line. And I know that slope is equal to rise over run. So it seems like, yeah, that really is just the literal quotient, dy divided by dx. But I need to be careful. Okay. Here, I've written the formula for the differential of a function, but where x is a specific value, x naught. So I'm not just talking about an arbitrary tangent line, I'm talking about the tangent line at x naught. So rise is that particular slope of that line times dx. The general formula just has f prime of x here, and then I need to, if I want to evaluate it for a particular function, I need to plug in for x and for dx. I've just already plugged in for x here. Okay. Now, this is certainly true, but dx and dy, we were saying, are variables that are related to each other by this equation. Dx is a variable representing the run, and that could be 0, because I don't have to move away from that point. If I don't move away from that point horizontally, the y value won't change. I could plug in 0 for x, and then dy would be 0. If the run is 0, the rise is 0 as well. So on their own, dx and dy are allowed to be 0. If one is 0, if dx is 0, dy is automatically 0 as well. Okay, but I can't say that this represents 0 over 0 in that case. Okay. dy by dx takes into account the limiting process. If I work with the curve and I calculate delta y and delta x, so I'm calculating the slope of a secant line, I'm taking the limit, as delta x goes to 0, of the slope of that secant line. And that limiting process is part of this symbol. So, if dx isn't 0, then I can think of dy by dx as being the literal quotient, the rise divided by the run. But rise and run are allowed to be 0. This point is on this line. Okay. So again, that quotient symbol, that dy by dx, is a little bit richer than just rise divided by run. It's the limit as the run goes to 0 of the rise over run on a secant line. Okay. All right. We've also been using rise equals slope times run if we wanted to get an equation of the tangent line. I would say in this case, y minus y naught. I'm just going to, actually, let's say y minus f of x naught. So this would be the point x naught, f of x naught, would be f prime at x naught times x minus x naught. And generally what we do is we add this over and we name our y value L of x to indicate that it's the tangent line, not the original function that we're talking about. Now this just gives me a slightly different way of viewing this. Whoops, f of x naught. Okay. So this is saying this is the y value on the tangent line. That's what L of x represents. This is saying it's the y value at the point of tangency and then let's look at what this is. X minus x naught, that would be my delta x, which I usually choose to set equal to dx. We're taking a look at, whoa, this is an x naught. Oh, I'm so sorry, I wrote f prime of x when I meant to write f prime of x naught. Okay, f prime of x naught times dx, that's my dy. So this is saying the y value on the line is equal to the y value at the point of tangency plus some change. Here's a point on the tangent line. What's the y value? Well, it would be the y value I start at here plus this amount of change, and that vertical change right there is my dy. So it just gives me a slightly different way of looking at the equation of the tangent line. Most important thing I think I said in this video is that this is more than just the quotient of dy and dx individually. When we were talking about the chain rule and we were using differential notation, I mentioned that you can't use differentials to prove things because you can't just cancel a differential if you have the same differential on top and on bottom, because they are variables and they are allowed to take on a value of 0. So while we do have a meaning for dy, and we have a meaning for dx, and we have a meaning for dy by dx, we need to be careful. This is more than just the literal quotient of rise and run.